Hello, welcome back to the channel. So let's continue our discussion on improper integrals with unbounded integrands, and let's solve this definite integral over here. But before we solve this definite integral over here, I would like to mention that this is definitely not the correct approach in order to solve this definite integral over here, because you can clearly notice that your fx is 1 upon x square. That means your function is not defined at x equals 0, but for your definite integral, your interval is lying between -1 and 1, right? Which includes the x equals 0 point. So that is why you'll have to deal with the discontinuity point separately in order to solve this definite integral over here. So that is why you'll have to use the concepts that we covered in the last video and split this definite integral into two parts and then solve for this definite integral over here. You cannot directly calculate the definite integral like this, which you did in the proper integrals case, because this integral is definitely not a proper integral. This is the case for an improper integral, which requires different methods that we already covered in the last two videos. So now let's solve this definite integral over here using all the concepts that we covered in the last video. And this definite integral definitely follows the third case over here, where you have a discontinuity which lies in between the interval specified for your definite integral. And what we do in that case is we basically split the definite integral such that the discontinuity point is in the middle. So what we'll do in this video as well, in this definite integral calculation, since we have to calculate the integral from -1 to 1 for 1 upon x squared dx, what we'll do is we'll first split this definite integral into two parts such that we have 0 in the middle. So this would be simply -1 to 0 for 1 upon x squared dx plus 0 to 1 for again 1 upon x squared dx. And now we can use all the methods that we covered in the last two videos in order to solve these two integrals separately. So what we'll do is let's introduce two new variables, a variable a which lies between 0 and -1, a variable b which lies between 1 and 0. And in order to solve these two integrals, what we will do is we'll take the limit a approaches to 0 minus, and we'll solve -1 to a 1 upon x squared dx plus we'll take limit b approaches to 0 plus, and this will be basically b to 1 upon x square dx over here, right? So we used all the concepts that we covered in the last videos to get this definite integral expression over here. So if you didn't get this part, I'll highly suggest you to first watch my previous videos in order to get the full context of this video. So now we can proceed on solving these definite integrals using the normal methods that we know. So we know that the integral of 1 upon x square is basically -1 by x. So what we can do is the first expression will be limit a approaches to 0 minus -1 upon x from -1 to a plus limit b approaches to 0 plus, and this would be -1 by x from b to 1, right? And now we can simply plug in the endpoints in order to solve this definite integral over here. And after plugging the endpoints, this will basically become limit a approaches to 0 minus, the inner expression would simply be -1 upon a minus of -1 upon -1, right? So this would be -1 upon -1, right? And the second one would be limit b approaches to 0 plus, this would be -1 by b minus -1 over here, right? And now the final expressions with the limits would be limit a approaches 0 minus -1 by a minus 1 plus limit b approaches to 0 plus -1 by b plus 1 over here, right? So now you have the final expression with the limits, and you just have to take the limits in order to get the final answer, right? But here you can clearly see that if you take limit a approaches to 0 minus for this expression, this limit is not defined, and similarly this limit is also not defined if you'll take limit b approaches to 0 plus in this case, right? This will go to -infinity, and this will also go to -infinity, right? So that is why after solving these two limit calculations, your definite integral does not exist, right? It does not exist, or the integral is divergent, which basically means that your definite integral diverges and it does not have a real solution to the answer of this definite integral over here, right? So that's it for this video. Again, the main takeaway from this video is whenever you're calculating definite integrals, always check if your function has a discontinuity point in between the intervals specified for your definite integral. And if it has a discontinuity point, then you'll have to use all the methods that we covered in the last videos to solve definite integrals with unbounded integrands. So feel free to comment down on this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.